Assalamu alaikum. So the lesson today is about system of equations. So we are going to learn today how to solve 3 by 3 system of equations using elimination method. So keep in mind the way we're gonna use to solve 3 by 3 system of equations using elimination method. It involve the 2 by 2 system of equations using elimination method. So please, if you have no idea how to solve a 2 by 2, take a look at lesson 4 and watch the video about how to solve 2 by 2 system of equations using elimination method. So if you have an idea how to solve it, so then it's okay. So we can start the lesson. Okay, so given, so let's pick a system of 3 by 3. So given a 3 by 3 system of equations, so I have ax plus by plus cz equal d, a1x plus b1 y plus c1z equal d1, a2x plus b2 y plus c2z equal d2. So this is my 3 by 3 system of equations. So the way how we solve the 3 by 3 system of equations using elimination method is we need to transform the 3 by 3 into 2 by 2. And we already know to solve a 2 by 2 we need to transform a 2 by 2 to one linear equations with one variable, which is 1 by 1 if you want to say it like this way. So that's the process how we solve 3 by 3. So we're going to transform the 3 by 3 into 2 uh, by 2. So how to do so? So first thing, we need to pick two distinct combination of two equations. So choose any two distinct combination. I can choose 1 and 3, 1 and 2. I can choose 1 and 2, 2 and 3. So any two distinct combination of two equations will work fine. So this is your choice. So any two you want to pick is your choice. So this is the first thing we do. So first choose any two distinct. So don't choose the same combination. I choose 1 and 2 and then I choose 1 and 2. It makes no sense. So, and it's gonna lead you nowhere. Two distinct combination of two equations. For example, I choose 1 and 2, 2 and 3. But again, the choice of the combination is yours. So I choose the first equations and the second. Then I choose the second and the third. So I choose ax plus by plus cz equal d. And I choose a1 x plus b1 y plus c1 z equal d1. Then I choose 2 and 3. The order of the equations again is your choice. You can put the 2 first and the 1 after. It's your choice. How you organize yourself is always your choice. So here I will have a1 plus b1 plus c1z equal d1, and I have a2 x plus b2 y plus c2 z equal d2. So those are my two distinct combination. This is my first, this is my second. All right, so now what do we have? We have uh, 2 by 3 system. You see I have two equations and 3 unknown. Here I have two equations and 3 unknown. So we don't know how to solve the 2 by 3 system, but the idea behind that steps is I need to change from 2 by 3 to 2 by 2. I will change those two combination from 2 by 3 to 2 by 2. So the idea here, I need to eliminate one of the variables. So I need to eliminate the same variable from the first combination and the same variable from the second combination. So if I eliminate x from the first, I will eliminate x from the second. If I eliminate y from the first, I will eliminate y from the second. If I eliminate z from the first, I will eliminate z from the second. So the second step is you need to eliminate the same variable from both combination. So you're going to use the concept of the LCM, so which is the least common multiple of the coefficient of the variable that you want to eliminate. So second, use the elimination method to eliminate the same variable from both combination. So by using the LCM concept, which is the least common multiple. So that's the idea behind. Idea here, pick my system first. Is a plus c y plus cx plus p1y plus c1z equal d1. This is my first combination. My second is second and the third. So a1x plus b1y plus c1z equal, this is d1, d1, and a2x plus b2y plus c2z equal d2. So now I'm going to use the LCM. So let's suppose, so let M is the LCM of A and A1, and M1 is the LCM of A1 and A2. They may have the same LCM, they may have different LCM. So this is what I choose, two different letters, just we're assuming they may be distinct, but they may be the same, so we don't know. So we know that the LCM is the least multiple, which means it's a multiple, which means that M can be equal to a number times A, and M can be equal to another number times A1. And the same thing here, so M1 is the LCM of A1, so it can be equal to another number times A1, or M1 equal another number times A2. So this is not all, this is AND, so I need to use AND here. So this is the idea about the LCM. So what I do here, the number that times A give me M, I multiply the first equation by that number. And the number that times A1 to get me M, I multiply that number into the second equation. So here I will multiply by R, and here I multiply by T. So which means I will multiply the first equation here by R, and here I multiply this one by T. For the second one here, I will multiply this one by R1, and I multiply this one by T1. So in that case, when I will have R times A, I will substitute by M, and when I will have T times A1, I will substitute it by So in that case, I will have the same coefficient for the same variable. So in that case, I can eliminate the x. So here my new system will be r a x plus r b y plus r c z equals dr, and we'll have t a1 x plus t b1 y plus t c1 z equal t d1. You see, when we have a number, so we're not going to see those two expressions. For example, if I have 4 here and we have 3 here, so it's going to be 12. And if I have 2 here and here we have 6, so here is going to be 12. So we will not see two things here. So this is just because it's abstract, so this is what you see. But this means that the two numbers are multiply each other. And same thing here. So I will have r1ax plus r1b1, r1a1x, r1b1y plus r1c1z equal r1d1. And the same thing here, we have t1a2x plus t1b2y plus t1c2z equal t1d2. Now we know that this product is the LCM, which is m. So I'm going to substitute that one by m and I substitute that one by m. So here will be mx plus rby plus rcz equal dr, and this will be mx plus t b1y plus t c1z equal t d1. And the same thing here. So here it will be m1, and here the same thing is m1. So it's going to be m1x plus r1 v1y plus r1 c1z equal r1 d1. And here will be m1x plus t1 b2y plus t1 c2z equal t1. This is d1, this is d2. Now, as you know about elimination, so when the coefficients are the same in terms of value and sign, we subtract the equations. So here we assume that they have the same sign. So what we'll do, we will subtract the two equations. So here I will subtract the first and the second, and here I will subtract the first and the second. So this is minus and this is minus. So we'll end up having, and at the same time I will subtract, I will combine like terms. So this will cancel out and this will cancel out because it's gone. So here we have y. Then we cancel I will subtract the coefficient of the first minus the second. So it's going to be y times the coefficient of the first minus the coefficient of the second plus, and here we have z times the coefficient of the first minus the coefficient of the second. So this will be equal dr plus gd1. The same thing here. So we'll have y times the coefficient of the first minus the coefficient of the second plus z times the coefficient of the first minus the coefficient of the second, and will be equal to this difference. So I will do it in two steps here, but let me see if I can just move this a little bit here. There we go. Okay, so here we will be, so let's put a line here, at least you don't get the difference. So it's going to be r1 d1 minus t1 d2. So now what I will do, I will name this, because this is a number. If I have number here, this will be only one number, or it's going to be one digit or two digit, but it's going to be just one number. So I will name it by capital A here. This is capital B, and this is capital C. So the whole thing is capital C, the whole thing is capital B, and the whole thing is capital A. The same thing here, I will name this one capital A1, this is capital A2, B2, B1, and this is capital C1. So in that case, my system will be very, very simple. So now what I will have that new system, which is AY plus BZ equals C, and I will have A1Y plus B1Z equal C1. So why I choose those as a number? Because if they were numbers, so we will not have this expression like that. So we will have two numbers minus each other, so it will give me one number. So this is why I change this one to be a capital A, which is a number that represents that expression. B is a number that represents that expression. C is a number that represents that expression. Just think about it. If it was 2 times 3 minus 3 times 4 or something like that. So we will not have the whole expression times y. So of course you can simplify and evaluate this expression. So when you evaluate the expression, it will give you one number. So we assume that number is capital A. The same thing for this expression and the same thing for this expression. So that's the idea behind. Now, after I eliminate my x, you see what we end up with? We end up with a system with two equations and two variables, which is a 2 by 2 system. And we know that what we should do right away, we need to check my Isel test. You see, to check what type of solution I have. Is it consistent or inconsistent? So I just check the ratio and see what I will get. So you apply the ratio as you learn on lesson 1. Now let's suppose, so if the system is consistent and dependent, so what you need to do, you need to apply the lesson 4, which is how to solve a 2 by 2 system of equations, so which gives you the direction how to solve a 2 by 2 system of equations using elimination. So I will not go through how to solve this because uh, this is in lesson 4, which is we learned already. So I just need to put a note here. So if the system is consistent and dependent, so please look at the lesson number 4. So watch lesson 4. So which is the solve 2 by 2 with elimination method. So in terms of Isel test, you can check lesson number 1, which is give you introduction to system of equations and introduce Isel test. So look at lesson 1. All right, so this is the idea behind how to solve 3 by 3. So let's do some practice. So to apply the concept and see how we get the results. So let's do a practice. All right, let me pick a system. So suppose I will have minus x plus y minus 2z equal 8 and 3x plus 4y plus 2z equal minus 26 and I have minus x minus 6y plus 2z equal 10. So this is my system, 3 by 3. So this is my first equation, this is my second, this is my third. Now what I do, I'm going to pick a combination of 2 by 2. Either I pick the first, the second, or the second, the third. So the choice is mine. So, but always choose the easiest one. So for example, I would pick the first and the third, and I pick the second and the third if I want, or I pick the second and the first. So it doesn't matter which combination I pick, but I just need to pick two distinct combinations. So I will pick the first and the second. So minus x plus y minus 2z equal 8, and 3x plus 4y plus 2z equal minus 26. And here I will pick the first and the third. So this is the first and the second. And I will pick the first and the third because I'm really lazy. I don't want to multiply. This is already there. Same sign, same coefficient. I just need to subtract. I don't need to do anything. I don't need to look for the LCM. So minus x plus y minus 2z equal 8, and minus x minus 6y plus 2z equal 10. Here I don't need to look for the LCM here. Well, I did not multiply here by anything because the LCM between 1 and 3 is 3. So what I do, I just multiply the first one by 3. That's it. You see, this is the type of choice I want you to do. So choose a combination that is easy for you to do. Work hard, but be lazy. So minus 3x plus 3y minus 6z equal 24. Here we have 3x plus 4y plus 2z equal minus 26. And here I don't need to do anything, so I will leave it like that. So here, let me do it right away here. I don't need to write it down again. So here I subtract because the same sign, same coefficient. So when I subtract, so this will cancel out. So I will have 7y because minus become positive. And here minus 4z. 8 minus 10 is minus 2. Here when I subtract, you see, oh, here I don't subtract by the way. Here I add. So here we add. So this means this is cancel. If I subtract, I will have minus 6x. So we'll add here. So it's going to be 7y, and here's going to be minus 4z, and here will be minus 2. So my new system will be this form: 7y minus 4z equal minus 2. 7y minus 4z equal minus 2. So either I subtract, so when I subtract, I will end up having 0 equal 0, which is true. So in that case, we have consistent dependent system, so we have infinite of solution. So this is infinite solution. You see here, I didn't use the Isel test because it's clear. So it's when I see it, they are the same. So I did I just subtract, I will end up with a true statement. So I conclude infinite of solution. So if I want to use the Isel test, so I will end up having this. So look at this. I will have 7y minus 4z equal minus 2, 7y minus 4z equal minus 2. So I do my ratio, 7 over 7 minus 4 over minus 4. So let's see what's the result. 1, 1, they are equal. I check the other ratio. So this is 1, it's going to be equal, then I conclude. You see, in my case here, the Isel test will take longer than just go for and use elimination again to check for the solution. But you have to notice that they are the same equations, or they are different in terms of the result, which is the C value, but the coefficient of x and of y and z are the same. So in that case, you can conclude there is no solution. But for our case here, I see that the Isel test is not good for me. So what I do, I just go further and conclude because I see it's the same equations. That means by the way is infinity of solution. So here again, you see they are all equal. So this is consistent, dependent. So infinite solution. So try if you get to that type of equations, but the coefficients are really weird, then use the Isel test because it will take you longer to conclude. But the Isel test will make it shorter. So always choose the short way. So this is my advice. All right, so another example. Let's do another example. So suppose I want to do that one. So I have minus x minus 5y plus 3z equal minus 8 and 4x minus 6y plus 5z equal minus 21, 5x plus 4y plus 5z equal 16. So here again I'm going to pick any two combination. So I see that the coefficient of the first equation is 1, so I'm going to choose my combination 1, 2, and 1, 3, because at the end I will multiply only the first one by 4 and 5, so I don't need to look for the LCM. So my combination will be 1 and 2, and 1 and 3. So this is going to be my combination, minus x minus 5y plus 3z equal minus 8. And I have 4x minus 6y plus 5z equal minus 21. And I have minus x minus 5y plus 3z equal minus 8. And I have 5x minus 6 or minus 4y plus 4y, sorry, plus 4y plus 5z equal 16. So this is how we choose our combination. Like I say again, you can choose any way you want, but always choose the easiest way. If you want to prevent the LCM, always choose the right combination. So here I want to prevent the LCM, so I just need to multiply the first one by 4 and multiply the first one by 5, then I'm done to eliminate the x. But like I say here, you see from the beginning, I know what I want to eliminate. That means choose the equation based on what you want to eliminate. So I want to eliminate the x, so I will choose 1 and 2, 1 and 3. If you eliminate the z, if I want to eliminate the z, I will do what? I will choose 2 and 3 and 2 and 1, because 3 and 1 will be the same thing. Look the three equations and check which one you can eliminate first, and this will tell you which choice of combination you have to choose. So here I will multiply the first one by 4 and I multiply the first one here by 5. So here I will end up having minus 4x minus 20y plus 12z equal minus 32, 4x minus 6y plus 5z equal minus 21. Here again I will have minus 5x minus 25y plus 15z equal minus 40. And here we have 5x plus 4y plus 5z equal 16. So what I do now, I want to eliminate same coefficient, different sign, I add. same coefficient, same sign, you subtract. Here the same thing, I will add. So then I will end up having the following system. You see, when I told you earlier, you see when we have coefficient, you see it's become a number. So we will not have like we have A, B, and C. Those are just way to present those number in terms of alphabet letter. So here will be cancelled out. So here when we add, we got minus 26y plus 17z equal minus 53. And here, so this has cancelled out, so we'll end up having minus 21y plus 20z equal minus 24. So what is my system? So my new system, which is a 2 by 2 system, will be minus 26y plus 17z equal minus 53, and minus 21y plus 20z equal minus 24. So this is my new system. So what I do now, I'm going to use the Isel test. So I have minus 26y plus 17z equal minus 53, and minus 21y plus 20z equal minus 24. So I'm going to use the Isel test. So minus 26 over minus 21, and we have 17 over 20. So obviously they are different, they're not the same. So which means the system is consistent and dependent. So the system is consistent and dependent. So which means there is a solution. So I'm going to use the elimination method, which is we learn in lesson number 4 to solve that system. So what I do here, you see, I know that 26 and 21 are coprime, 17 and 20 are coprime. So they are a coprime number, which means the LCM is the product of the two number. So 21 and 26 is a big number, so what I do, I choose 20 and 16, so that means I want to eliminate z first. So what I do here, I multiply the first one by 20, multiply the second equations by 17. So I will have minus 26y plus 17z equal minus 53, and here minus 21y plus 20z equal minus 24. So what I do, I multiply the first one by 20, and I multiply the second one by 17. So in that case, I will have the same coefficient of z. So then, and the sign are the same, so I will subtract. So when we multiply 20 with 26, so it's going to be minus 520y plus 340z equal minus 1060. 17 minus 21 is minus 357y plus 340z equals minus 408. Now what I do, I subtract both equations. So what I do, let me make a copy of I'll put it here. So in that case, we'll save time. Now what I do here, I subtract because the coefficients are the same and the sign are the same. So now here when we subtract, we end up having minus 163y. This is cancel out, equal minus 652. So divide by minus 163, divide by minus 163. So y will be equal to 4. Now I pick one of those equations. So which one I pick? I pick anyone. Let's pick the second one. It's more easier. So I have minus 21 times 4 plus 20z equal minus 24. So minus 84 plus 20z equal minus 84, minus 24. All right, so minus 24. So I add 84 both sides. So I got 20z equal uh, 60 divided by 20. So z will be 3. So I got my value uh, of y. I got my value of z. So this is my z. This is my y. So what I do here, I'm gonna go back into one of the equations and solve for x. So what is the equations? Here we go. So here, which one is easy to solve is the first one. So I'm gonna pick the first equations. All right. Now we know that y I think is 4 and z is 3. So y is 4 and z is 3. So we have y equal 4, z equal 3. So I substitute back here, minus x minus 5 times 4 plus 3 times 3 equal minus 8. So minus x minus 20 plus 9 equal minus 8. So minus x minus 11 equal minus 8. So plus 11 both sides. So minus x equal 3. So obviously x will be minus 3 if you divide by minus 1. So my solution will be, so always the solution is a triple. So x, y, z. Don't write it down as x equal, y equal, z equal. Always use triple notation. So minus 3, 4, 3. So this is about consistent and dependent. So let's see about how we can do consistent and consistent system. So let's pick an equations, or let's pick system of equations. Minus 6x my plus 4y plus 4z equal 4, and we have minus 6x plus y minus 2z equal minus 15, and we have 3x minus y equal minus 23. So this is my first equation, this is my second, and this is my third. All right, so here the choice of two combination is not worth it. Why? Because I already have one, because the purpose of the two combination is to change from 3 by 3 to 2 by 2. If I have one of the equations is already, it has already two variables, so what I do, I don't even touch it. So I just choose the other two equations and try to eliminate the same variable which is not in the other equations. For example, here, the variable which is not in that equation is z. So what I do, I'm going to pick those two and eliminate z. So you see, this is less work. So I don't have to pick, okay, the first, the second, and third, and second and third to eliminate, for example, x or y. I don't have z here. I eliminate z from the other. If I don't have x on the third one or the second one, so I eliminate x on the other. If I don't have y, I eliminate y. You see, less work. So what I do here, I already have one equation, so I will keep that one on the side, and I choose only one combination. I will not choose two combination here. So it's going to be minus 6x plus 4y plus 4z equal 4. And we have minus 6x plus y minus 2z equal minus 15. And again, it's not because the coefficient of x are the same, I'm going to eliminate x and keep the z. Keep in mind, I have x and y. That's mean I need to keep x and y here. So there's no choice, I need to eliminate the z. So here the LCM between 2 and 4 is 4. So this is the LCM between 2 and 4 is 4. So 4 is already here. What I do, I multiply the second one by 2. So this is exactly what I will do here. So I'll multiply this one by 2. So I will end up having my new system will be minus 6x plus 4y plus 4z equal 4. And I will have minus 12x plus 2y minus 4z equal minus 30. Okay, now what I do, the sign are different of the coefficient of z, so what I do, I add. So here will be minus 18x, here will be 6y, this is cancelled out, and here will be minus 26. Now, can I simplify? Yes, I can simplify by, if I add, I can simplify here by 2. But you know what? It's not gonna be helpful a lot. So what I do, let me write my system. So I got 3x minus y equal minus 23. And we have my minus 18x plus 6y equal minus 26. Now let me use my Isel test. So I have 3 over minus 18 minus 1 over 6. So if I simplify here, I will have minus 1 over 6 minus 1 over 6. So they are equal. So I use my third minus 23 over minus 26, which is 23 over 26, which is different than minus 1 over 6, which means the system is inconsistent. So this is a consistent system. Which means no solution. So this is the idea behind how to solve a 3 by 3 system using elimination. So I hope that you understand the concept behind, and please to get it better, please see the video about how to solve 2 by 2 system of equations using elimination method, which is lesson number 4. And I hope everything is clear. So please, if you have any comment that will improve my way of teaching, please do so. And thank you for watching the video, and Assalamu alaikum.